Hello and welcome to this tutorial about how to use Git. So the point of this tutorial is just to give you a really brief overview of what you need to get started using Git for your version control. So the first thing that you need to know about Git is what it is. So Git is a version control system. So it's a way of storing all of your files in one place, and so if something happens, you can get a backup, and it's a version control. So as you make changes to your code or to your project, it will track your changes. So if you save a copy of your code that's broken or doesn't work, you can always go back to a working version. Git's also free and open source, which is fantastic for smaller companies or for people who want to add their own changes or personalize Git in a way that they'd like. It's also distributed. So it's your files aren't sitting on one big server. It can be done locally. And it's also commonly used. So Git has a really big user base, which can be really helpful when you're learning how to use a new project. So as a student, why would you want to use Git? What are the benefits? Well, like I mentioned previously, it's free, which is awesome. So you can play with it and not having to worry about paying a fee or buying the full version or anything like that. You no longer have to worry about losing your code. So the night before your project's due, if your computer crashes, you still have a copy of all your work. And it's distributed, so it's not sitting on the server at your university. You have control and you're able to deal with it there. And because it's commonly used and it has tons of tutorials and lots of information online to help you learn this product. So today I'm just going to cover the basics of how to get yourself going with Git. That's going to include how to create your repository, how to add your files, and how to do the basic commits, as well as branching. So the beginning of how to work with other people on a project. So the first thing that we're going to go over today is the git initialize command. So you use git init to create a new repository. And a repository is where you store your files for an individual project. So for this tutorial, I'm going to assume that you have Git installed. And if you want more information on that, I'll have a link to how to install Git at the end of this tutorial. So I'm doing my work on my desktop today. So here's my desktop. I have a couple files. So the first thing I'm going to do is create a new folder. And in this folder, we're going to create a text file. So right now there's nothing in my file. And if I show my hidden files, still nothing. So we're going to start by creating just a simple text file. So, hello world. And so, as you can expect, that's now inside our folder called foo. In order to add this to Git, it's quite simple. All you have to type is git init. And that's going to initialize an empty Git repository. So now if I look in my file, it looks like nothing has changed. But it has added the .git file. So if I show the hidden files, now we've got this awesome .git file. So this does your version tracking and keeps track of all the changes you made. So now that I have Git installed and initialized, the next step is to actually add these files to the repository. One thing to note is that when I create the new repository, it doesn't add any existing files. So a little trick is called git status. And git status simply tells me that I'm on my branch. This is going to be my first commit, so I haven't done any commits before. And I have an untracked file called text. And it'll give you little hints. So the first thing you want to do is I want to git add text.txt to my repository. And now it's added to the list. So once I have added my new files, it's ready to be committed. So the steps are, once you've created your repository, add your files and then commit them. So if I do git status again, we can see that we're ready to commit, and that when I do a commit, it'll add my new file. So now I can just type git commit, and it'll ask me to create a message. So anytime you make a commit, I highly recommend you add a detailed message of what's going on. So if I have to go back and change my code, let's say I submit something that's not working to my repository, and then I want to go back to an area of my code that works, I would go through my previous commits, and I would choose an old commit based on the message. So for this example, I'm going to keep it simple and just say this is a test commit for the tutorial. And save it. Now, if you wanted to cheat and you didn't want to go and have to open up a text editor to do that, all you have to do is do git commit -m and then just write your message. And then when you commit, it will save that message like it did previously. And you'll notice that when I try to commit and there's nothing there, it just lets me know. So Git has a fantastic feature where it really keeps you in the know of what's going on. You always know what's happening with your repository. So those are the basic functions. We have covered git initialize, git add, and git commit. And those are the basic steps. So you're done, basically. You have set up your repository and you can now save things and save your changes. But let's say you're not working in a brand new file. Let's say you've been working on a project for quite a while, such as Temp Game, which is a little HTML game I've created for school. And I want to add this to my repository now. Well, the first thing I would do is go into the file, and as you can see, it doesn't have a repository connected to it yet because there's no .git file. So I just simply do as we did the first time, git init, and now I've initialized my new repository. So if I do the check, I have all of my files as well as my .git. So you already know the steps here. You want to git add your files. But since there's so many and you don't want to take the time to add them by hand, you can just do git add dot, which is the period. And if you do that, it will add all the files in the folder to your repository. Now, you don't want to do this if you're only working with specific files. So if I have a folder of temp code or old code that I'm not using anymore, you may not want to include that, so I wouldn't use the period then. But if I do a git status update, you'll see that it's ready to add all of these new files to my Git repository. So git commit, adding the files for my game, and I'm good to go. Another git command, and that is the cloning command, git clone. So git clone is kind of similar to checkout if you've ever used Subversion. It allows you to get a copy of a current repository. So let's say, for example, you are working on a team project and you're joining in late. You could get a clone of the current repository to work on your own. This is most commonly used for projects that are open source. So let's say that I am building a game of tic-tac-toe and you've offered to help out on it. You could go and clone a copy of my tic-tac-toe game and work on it for yourself. It really allows you to contribute to other projects, and that's one of the powers of Git. So we're going to do that today. I actually have a tic-tac-toe game that we're going to use as a guide. So we are still on my desktop, and we have our game and our original file here. So now all we're going to do is we're going to do git clone my tic-tac-toe game. Now, this is currently one of my repositories. It's on my computer, but we're going to pull it from GitHub, which is a site I'm going to explain in more detail in a little bit. So all we're going to do is git clone, and then the URL for wherever this repository is stored, and it's currently being downloaded to my desktop into a file called tic-tac-toe. So really simple. Now I can go into my tic-tac-toe game, and I have all the files that I need to both run it and develop it. This goes from the build files to the readmes and so forth. So I now have a full working copy of the tic-tac-toe game. So I can go in and make changes like we did before. And this is local, so anything that I change on my clone copy won't affect the original project. So that's it. You now know the basics of what to do with a repository. You know how to create one, you know how to clone one, and you know how to do the adds and commits. So now we're going to move on to some of the more powerful features that Git has including branching, pushing, and pulling. Branching allows you to diverge from the main line of development and focus on a feature without touching the main code. So basically, how Git works, all your commits are connected through a complicated linked list. And the master branch is always attached to the latest commit. So you'll notice as you're doing your adds and your commits on your local repositories, it always says you're on the master branch. Basically, that's your current node, and it's the pointer that follows through all of these commits. So, but you may be working on a new project, or it's a school project, and you're going to work on this new feature, but you want to develop it without breaking the code for everyone else who are working on different features. In order to do this, you want to work on your own little branch where you can do all the development you need without breaking the code for everyone else. It's a really handy little thing. So I'm going to show you how to do that. So what we're going to do is, we're still inside our tic-tac-toe game. So just for simplicity's sake, I'm going to move to our temp game from before. So now we're here in our temp game, and all we're going to do is we're going to say git branch. We're going to call it, I like using the initials of everyone on my team if they're each going to work on their individual branch. But we're just going to say, we'll call it as a feature. So we're going to say readme changes. And that's the name of our branch. So now if I go to git status, I'm on the master branch still. What happened? I created this branch, and it's still there. The branch exists, but you have to physically transfer where you're working to the new branch. And we do this by a checkout. So I'm going to do git checkout readme changes. So now I've switched my branch to readme changes. Makes sense, pretty standard. So now I still have a copy of all of my work from before. It just takes a copy of the last commit we were on and allows me to do whatever changes I want. So for example, I could go into the readme and I can make some changes here. So changes. And then if I do my git status, the changes are made. And so now I can just add my changes like we did before, and then commit them. Perfect. So this was changed on my local branch only. So this is a great way to do all of your work here, and anything I break, anything I mess with isn't going to affect the rest of my team. So once I have a working copy of my feature and I'm ready to add it to the master branch, I can do that. And that's something we're going to talk about in a minute. Been looking at.
So we're going to take a break from the clips that we've been looking at.
So to review GitHub. So when I started working with Git, I got confused what the difference between Git and GitHub was. GitHub is a community where your repositories are public, and it allows other coding enthusiasts to help you build your project. So if you're out talking to other developers, they may reference their GitHub account and to go check out their GitHub. And that makes you think that GitHub is the version control system, and it's not. It's just a project that is able to let other people view your repositories, including yourself. So here we've got a copy of my GitHub account, and this is the main page when you log into Git. It shows you all of your repositories and what your friends or followers are doing. So for example, we can go to my Git account, and one of the benefits to GitHub is that you're allowed to have public and private repositories. So these are my repositories, and a couple of them are public, but I do have one or two private ones for work that I don't want to release and have other people view yet. It's also great because it tracks all your changes. So I can go into, let's say, one of my repositories, and I can go to the commits, and it'll show me all the data, and I can see who on my team has done what commits and when they were done, so I can see what changes were made. I can also go and look at a graph of contributions. So if you're working on a team project, I'm able to create a graph, and this project was done last semester, so it's a little old, and I can tell who did what commits when, and what they were related to. This is also great for the students to use. So I use GitHub as part of my development portfolio. So now anyone who is interested in hiring me for a job or maybe an internship, I can give them a link to my GitHub portfolio and they can view all of the projects that I've worked on that I've released through Git, as well as see my coding style. So if you do a lot of commits and you're really active on GitHub, it will give potential employers a chance to see your work and see more than just the resume you hand them. So what we're going to do is I want to take the temp game we've been working on. So our temp game that we have on my desktop, where we have that little game I built last semester, we're going to add that to a repository on Git. So as you remember from earlier, this file is already part of Git, so I already have a local Git repository. And now I just want to add it to GitHub so that I can show it to future employers, as well as maybe have some of my friends who live in different areas help me work on this project. So what we're going to do is from here, I'm going to click Create a New Repository from the GitHub website. We're going to give it a name. I'm going to call it Temp Tutorial Game. And then we're going to make it public. You could make it private so only you and certain people could see it, but that's not really necessary. So you create the repository, and other repositories can create on GitHub. So if I went to my main page, you would now see the temp tutorial under my list of repositories. So now what we have to do is we have to connect my GitHub repository to my local one on Git. And in order to do that, you're going to need the URL at the top. So this allows me to make a copy of it through the command line and add it to my GitHub account, so that whenever I make a commit or add anything to the project, at the same time it will add all this information to my GitHub repository. So back at the terminal, what we want to do is we are located within the right directory. And then all you need to do is go git remote add origin, and that is the GitHub repository. So the link that GitHub gave me is here, and I just copy that in, and I hit enter. And now I've connected my GitHub repository with my Git local repository. And the one GitHub is now called Origin, so that's the name we've given it. And like before, as I mentioned, my repository is called Master. So now this is where our last two commands come into play, and the example I'm going to use. So this is where we have pushing and pulling. And pushing is, like we mentioned in branches, when I want to share my changes to the master branch or to a different branch. And it allows me to do my working copy locally. I can make all of my changes on my master, and then I can synchronize it with my remote branch, which will be Origin on GitHub. So that allows me to work privately, and I can make as many changes as I want. I can even make the commits, but they won't get pushed to GitHub until I'm ready. And the same thing with pulling. So exact same scenario. I can pull information from my GitHub repository. So similar to cloning, I can pull in different branches and different information, and then work on it locally from there. So we're just going to do that right now. So the first thing I want to do is I want to git pull origin in master. And that just pulls anything that's currently in the repository. We're going to actually do this now. So normally what I would do is if I was working on a repository in Git and I wanted to pull the information, I could simply go git origin, git pull origin master. And that will pull everything that's currently in the GitHub repository to my local copy on my Git account called master. But since there's nothing in my repository, we're not going to do that. Instead, we want to push everything from my origin to my master. and it's asking for my GitHub account information. So now what it's doing is it's sending all of the information from my repository up to my GitHub branch called Origin. So as you can see, it's written all the objects, so all 15 of the different objects, and it's pushed everything there. So if I do git status, nothing's untracked, I'm still on master. And then if I go back to my Git account, under my repositories, we'll see the temp tutorial game with the README that we added. And it shows the commit that we made when we started this project. So that's the basics of pushing and pulling, as well as what GitHub is and how it differs from Git and how you can use it to your advantage. And so the last thing I wanted to cover was the GUI for Git. So I like using the command line, but sometimes it's nice to have a visual interface to work with. And some people really don't like having to work on the command line. So the other option is to use a GUI. Git has a couple different versions available through GitHub. So this is the Mac version GitHub application, and it's a really simple interface. It lists all of my local repositories that I've added, and so I can go through and see my GitHub accounts as well. So for example, we'll go back to the tic-tac-toe one, and so I can open up that repository, and it can show me a history of all the changes I've made. These are all my commits, as well if there are any branches, and there are no branches in this tic-tac-toe game. And I can make any commits and add files from this GUI instead of using the command line. So I simply add the summary, which is what we did with -m, and I can commit all the files I want. So the only ones that have changed is the automatic Mac files from my computer. Otherwise, this would list any other files within my tic-tac-toe directory that were changed since my last commit. And I could check or uncheck the ones I wanted to commit, and then just hit commit and sync. And it would add all my files, commit them, and then sync it up to my GitHub account all in one step. This is really useful if you don't like working through a terminal. So that's basically it for this tutorial. The only things I haven't covered, there are a couple more commands with Git that are incredibly useful, such as merging. So if you're working on multiple branches, merging files together can be challenging. But I'm not going to cover that in this tutorial. And so that's it. So below you'll see links in the comments to a whole bunch of different tutorials that I would recommend, including a link to GitHub and how to set up a Git account. And hopefully you found this helpful.